Okay, today we'll try to build or to explain how to build a GPT-like model. Okay, so in the first step, we'll try to firstly to segment it in 5 steps. We have data preparation, and we have model define model components, and we have construction. After that, we'll construct the model. After that, we'll do model optimization, and last we'll have the text generation. Okay. Lastly is the practical some mathematical background. For data preparation, we will first obtain the dataset and we'll do some pre-processing. For obtaining, we'll download, for example, Shakespeare dataset. After that, we'll read the data into memory to pre-process it. Next, we will do character mapping. So we'll identify all the unique character in our dataset and we'll do a mapping for integers. Then we'll encode our dataset based on that new character mapping. This is the code for downloading. Next, the code for reading, and after that, the code for creating the character mapping, and after that, for encoding in PyTorch. Next, we'll do data preparations. After the data preparation, we'll create the model components. We'll create them, and in the third step, we'll do the construction. First, we'll do the token and positional embedding. Next, we'll talk about attention mechanism. After that, we'll speak about transformers block. So for token embedding, we'll define an embedding layer to convert token into dense high-dimensional vectors. So and after that, we'll do also the position encoding. We'll implement a position encoding layer to make the model able to understand the position of the tokens within the sequence. Next, we'll do the single attention head. We'll craft an attention head capable of computing key, query, and value vectors, followed by a softmax operation to obtain attention weights. And we'll extend the single head mechanism to multiple attention heads to allow model to focus on different aspects of embedded simultaneously. So that is the next. After it, we'll assemble the transformer block that will combine all the multi-head attention mechanism with a feed-forward network. Employing layer normalization and residual connection to stabilize and enable learning or enhance learning. So this is the example for embedding table. We'll use the embedding. We create the embedding. For that, for also position encoding, we will do position encoding for the embedded data. We'll create a single attention head, okay, and that attention head will do some linear operation or mathematical operation on the tokens sequence, and multi-head will do that for multiple levels of the encoded data. Last, we'll create a block where we will put the multi-head attention. After that, we'll do a feed forward to let that block feed that data forward in the neural network. We'll construct a Binagram language model using the inheriting from NNN.model in PyTorch. We'll need to define the constructor and forward the methods. And next we'll do the next we'll do the model. Let me go back one little. Yeah, next we'll do the model optimization. We'll define an optimizer and train, and also we'll start the training process. So for optimizer, we have the gradient descent, the normal one, and we have the Adam W optimizer, a variant of Adam optimizer that indicate weights the decay for improvement of regulations. Next, we'll do the loop. For each iteration, we'll fetch a batch of the input target pairs and perform forward pass to compute the prediction and the loss. And then backward pass to compute the gradient, updating the model weights using the optimizer. Here is the example for creating the optimizer from it's building. It's available inside Python. And after that, also for the train law for each one, we'll do like we'll get a batch, we'll compute the model, and we'll do for the loss we'll backward, and for optimizer we'll step, and after that we'll zero the weights, so we can go to the next one. After that we'll do some text generation. We'll provide some text context, and after that you will do some, after you train the model, you try to generate some new text, providing to doing the decoding part of the model. Here we'll use our dictionary or our embedding, and we'll transfer that back to a text. And lastly, we also will dive into details in some mathematical operation like softmax and cross entropy loss and model optimization through gradient descent and back propagation. These elements are very crucial to